half of that coming from the European Regional Development. So we have 16 partners from 6 countries, so all of the North Sea region apart from Norway. Next slide. Next slide. So why do we need to encourage pollinators? Well, we know that they have huge economic value, about 15 billion euros, can be attributed to insect pollination across the EU. But unfortunately, wild pollinators are declining, like lots of insects, and this has been attributed to changes in agriculture, intensification, and also climate change. We do have honeybees, but they're not always as reliable or appropriate as wild bees. But member states are also meant to be assessing the estate of their ecosystem services and their economic value. And this was done in Belgium. This was estimated to be about 252 million euros, so huge economic value. But unfortunately, we don't really know that much about the abundance of pollinators. We know something about their distributions, but annual monitoring of pollinators is really in its infancy. So that is being addressed, but it's something we will also look at. And levels of pollination, the impact on crops are not routinely measured. And also, we do have things like agri-environment measures that can help, but they're not targeted, especially to crop pollinators at present. Next slide. So what is the pollination potential across Europe? So this map was generated by the European Joint Research Centre, and it's based on land use and potential to support pollinators, but also the flight ranges of those pollinators. And from this, you can see that there really is a low level of pollination across Northern Europe, the North Sea region having some of the lowest levels. Next slide. So the project rationale is quite simple, really. You've got, if you have few bees, rather sad and lonely bees, then you're going to have a lower crop yield and poorer quality of crops and lower profit. But if you can create an environment with lots of happy bees, then you're going to have crop yields and better quality and more profit. Next slide. So we know quite a bit about crop pollinators already from various studies across the world and in Europe. And we know the dependency of some of these crops on pollinators. So most of the horticultural crops are highly dependent, less so with some of the arable crops. But there's still gaps in our knowledge. We know that there's all different types of pollinators out there, not just honeybees, bumblebees, and solitary bees, but also hoverflies and flies. But we don't always know the relative importance of each type of pollinator. And in some situations, it may be individual species which are more important than others. We don't always know, the detail about whether it's short or long-term bees that are really providing it. And there can be variation between regions and cultivars and years. So there's still quite a long way to go, especially in determining the efficiency of different pollinators. So just visiting a flower doesn't always mean that they're the most efficient pollinator. Next slide. We also know quite a lot about what's out there in the environment. So here I've just taken the number of species that are typically found in field boundaries, and also put on alongside that the species that are found typically in wild flower mixes. And you can see that there's a peak in June, July, August, but the existing flower mixes tend to replicate what's already there. So they're generally providing a greater abundance of flowers in the landscape, but not particularly diversifying the number of plant species that are out there. And most of these early wild flower mixes are targeted at bumblebees. But we also know that non-crop habitats can provide a lot of resource as well. So there was a study that came out of Bristol where they measured the levels of nectar from different plants and then mapped the landscapes. And they found that these field boundaries were very important, hedgerows in arable land, but also that grassland has huge potential. Next slide. So what can we do to increase pollinators? Well, we know that sowing wildflower mixes can be beneficial. It's not always so simple as just going out and walking along and counting bees, because it is notoriously difficult to get estimates of total densities in a landscape. You can use a molecular technique where you measure the numbers of colonies of bees in the landscape, because all the workers in a bumblebee nest related. So this was done in some areas in Britain, comparing higher level scheme and entry level scheme farms. So the higher level scheme ones had 2.2% of sown-rich habitat, and we compared that to where there was none. And we found there was twice as many bumblebee colonies where these sown flower areas were. So this shows that just simple measures can have a big effect. And for some species, it was an even greater benefit. Next slide. And in this study, Tom Wood also looked at whether we can increase solitary bees and looked at those. And he found there's a really strong relationship between the number of plant species and the number of bee species, but we don't know whether this is increasing their abundance or not. And so that's something to also consider. But we do know that there are a lot of wild bee species out there. So 105 wild bee species were found just on some fairly standard arable land, and almost 300 flowering plant species. Next slide. And so what are we going to do in Bespoke? Well, Bespoke is a whole package. So we're looking, starting with the research. So we're developing more targeted seed mixes and evaluating those and seeing the benefits for the pollinators. And then we're also looking whether this can then have some knock-on effect in terms of levels of pollination. So we're looking at techniques for measuring pollination and doing this in the crops that we're working on. And we're trying to identify also the economic gains of putting these in, because that's always a key driver for the farmers. Then alongside this is some modelling. So we're trying to identify the areas of flowers that might be needed on a farm or a landscape, and also identify regions that may need improving. And as we saw from the previous map, a lot of the North Sea does need improving. And we're hoping that the results will feed into policy so we can improve the opportunities in agri-environment schemes. And then we'll be doing an outreach program, so demonstrating best practice, running training programs, producing guidelines, and reaching out to those that can help. And so hopefully all of this leads to high yields and quality, but also more flower-rich habitat. And alongside this, we have a communication program and also monitoring and evaluation. Next slide. So the monitoring and evaluation is really to make sure we're delivering the best out of the project. So we have an action learning cycle. We'll collect in-depth data on activities. So we're trying to learn from our experiences. So if we run events, we want to get feedback, work out how that's happening. But also the project as a whole, because it's a very complex project and involves all aspects of research and outreach. It's good to know whether the best way to demonstrate that and get the results out to the end users. And we're also using all this information so we continuously improve through the process. Next slide. But we do need your support. So financially, we only get 50% funding from Interreg. So if you want to come along with a suitcase full of money, that would be much appreciated. But also if you want to sponsor events, we'll be running lots of training events. There's opportunities there to get involved. We do need more demo sites and to demonstrate new seed mixes. And we can also potentially use some of those for research, training and knowledge exchange events. But overall, we just want you to also get involved, to encourage pollinators, use new mixes, use our guidelines, and get out there and help us improve the environment for pollinators. Thank you very much.
Thank you, John. And now, please, Lena Siegspraat from the University of Copenhagen.
Yes, I'm going to say something more about the development of bespoke seed mixes and management. And the background is this very intensive agriculture we have in our North Sea region with reduced place for non-crop habitat, biodiversity under pressure, with the negative effects on pollinators and on pollination, which again can negatively affect the yield of flowering crops. Next slide, please. And the objectives is to design and trial new and also established flower-rich habitats and make a network of demonstration farms where we can test and demonstrate these. And then to take some basic measures of the impact of what we do on pollinators, on pollination, and also on crop yield and quality at the key times of crop flowering, and to investigate current adoption of farm level practices to promote pollination. Next slide, please. So currently we have 65 demonstration farms established, and we have set a goal of at least 72. And of course, it's really nice that we are already so far. And we are covering a broad range of crops, from arable crops, cereals, field beans, rapeseed, flax, potatoes, sugar beet, to horticultural crops, sweet cherry, apples, plums, strawberries, raspberries, black currant, and also forage crops, grassland and alfalfa. And we're looking there at the flower strips and also kind of natural control. As you know, dandelions and things are also there without us working. And then we are designing and then trial the flower-rich habitats. And these flower mixes. Oh, please turn off your microphone, whoever is coughing. They are adapted to the crops and the pollinators visiting these crops. And then we should be considering the needs of those pollinators for both food and nesting site, overwintering sites. And that means that we should prioritize long-lasting structures, perennial native species that can be in the field for several years, mixes that together give a very long flowering period. So that means making diverse mixes. And such flower mixes will also have additional benefits for biodiversity and also support other beneficials like natural enemies. And this, of course, also includes other habitats like hedgerows, field edges, and meadows. And then we will look at the effect on the pollinators, abundance and biodiversity, and on pollination and resulting yield, considering factors like the size of these flowering areas or other habitats, how far they are from the plants we're looking at, and the time since they were established. And the last thing I think is probably underestimated, because when you look at the few studies that currently are there, the beneficial effect you get out of non-crop habitats and flower mixes increase over time. The little graph I included there is a very early result from this year here in Denmark, where we saw the pollinators and how they're distributed from the flower strip and inside the field, which indicate that there should not be too far from the flower strip. Next slide, please. So all of this then should be linked together with demonstration, where we can discuss these improved habitats and evaluate them, share them with the practitioners, growers, other stakeholders, and review them. And we want also to make improved habitat management guidelines out of this. And that was it. Thank you.
Thank you, Lena. Now we go to Janneke Bijkerk from Kruidhoek in Friesland, the Netherlands.
In the BEESPOKE project, we try to emphasize on the application of native perennial wildflowers, as this is best adapted to local circumstances and the local wild pollinators and natural enemies. In the BEESPOKE project, we aim to design mixes that are suitable for a particular area or country, and for this we aim to make a tool to be able to create these different mixes for different countries and areas. For this we use national databases for vegetation. Unfortunately, this is not available in every country at the moment. When buying your seeds of a mix, it is important that you buy them locally in your own country, so they are seeds that are genetically most compatible to your local wild pollinators and natural enemies. In the BEESPOKE project, we aim to design mixes from the species that are locally best fitting. So actually we aim to design a tool to create all different mixes for the different countries and different areas. For this we need information, of course, about the flora of a particular site, and we can use national databases of vegetation for this purpose. Unfortunately, not every country has this data available at the moment. Do you apply a simple or a diverse mix? It's fine to apply a simple mix, especially when there's plenty of species of wild plants in your area available for your wild pollinators. If this is not the case, it is best to apply a diverse mix on an area as large as possible. Bigger is better. It is best to try to plan as much flower fields as possible. Here it's also better to create big fields and wide margins instead of small. The bigger the better. And also I think it's advisable to use no or very little grass seeds, since they will take away the advantage of your herbs. Here's for some tips for best practices. When you're sowing, this is best to do it late summer or autumn. So August, September, October, November. It's fine to sow in spring, but there's some more risk for hot seasons and drought for your seedlings. When preparing the soil, sowing is always on bare soil. It's very important. When you have prepared the soil, it's important that it's not too airy for moist content for the seedlings. So it may be advisable to use a roll to compact the soil a little bit again. For the sowing, you can do this by hand or by machine, but it's important that you apply it evenly over the field and you don't need much seed. So you can, for example, mix it with sand to distribute it evenly over the fields. When preparing the field or performing the management of your field, it's important that you don't use too heavy equipment not to compact the soil. When you are sowing, it's very good that you apply the seeds not deeper than the size of the seeds, so very superficial in fact. If you have been sowing in spring, you have to check if the weeds are not smothering your field, and it may be necessary to once or twice make a cut for hay in the summer in order to prevent this. Yearly management would be 1 or 2 times, especially on more rich soil, cutting the field and making the hay, so removing the cuttings. Removing the hay is very important because it will help you maintain a flower-rich vegetation for many more years. For your wild pollinators and natural enemies, it would be best if whenever you take a cut and remove the hay, that you leave 15 to 30% of the field standing. Because then the bugs will have a place to hide, to overwinter, to get pollen and nectar from when the rest is cut short. It is important to never walk or ride over your field, and when you're cutting the hay, use light equipment. For more information on how to successfully establish a wildflower field, please check our project website, where you can download an easy-to-use guide on northsearegion.eu/bespoke.
Thank you, Janneke. Now we go to Dirk Albach from the University of Oldenburg, together with Regina Albers, Jendrik Holthuizen, and Matthias Pech.
Thank you. So the grasslands are a special community in agriculture because other than most other crops, they don't rely on pollinators. Nevertheless, they're dominating large parts of northern Germany and other parts of the North Sea region. So it's important to also investigate grasslands. And they have basically the problem that it's a question of yield versus diversity. And there are two strategies to overcome this problem. One is land sparing, in which you separate some part of your land to provide maximum diversity in this region and to do maximum intensive agriculture on the rest of the land. We follow the second strategy, the land sharing. We try to increase the diversity of the grassland as much as possible without compromising yield. For that, we designed special seed mixes, which we test next. And our standard ryegrass seed mix is compared with 4 other mixtures. And these are provided by our partner Miners Saaten. So the first mix that we compare is one in which we increase the number of cultivars. Usually you only have 1 cultivar of white clover in your ryegrass mix, but this has a very short flowering period. So if we increase the number of cultivars in the mix, we have 5 times a short flowering time. So the second mix is one in which we add plantain. Plantain adds other interesting aspects. First, it attracts different insects than bees, and it improves the nitrogen consumption in cows, which potentially decreases the nitrogen content in the urine. The third mixture is increasing legume diversity by not just adding white clover, but also alfalfa, Persian clover, hop clover, birdsfoot trefoil, and Alsike clover. So this will expand the flowering time and also the flexibility regarding soils. Finally, we add into the mixture 3 other grass species, which should provide increased yield overall, but especially they are designed to improve yield in dry years, as we experienced in northern Germany in the last 3 years. So we have 6 fields in which we have the field trials. 2 with sandy soils, 2 with marsh soils, and 2 in boggy soils. We have 5 hectares each, so this is quite large and will provide hopefully realistic results. All 5 hectares are divided into 5 pieces of 1 hectare each, and the seed mixes are sown next to each other. The results from this year demonstrate that the yield as measured by plant height is basically the same in all 5 mixtures. But next, we will also measure other measures of success for the mixtures with the benefit for the cows. That's netto energy lactation and usable crude protein, and the mixtures seem to be comparable. So what's in for the insects? As you can see here on the left, we have made mostly 4 different generalist bumblebees in the grasslands, and they mostly rely on white clover. But what you can see on the right is our distribution of hoverflies, and they rely less on legumes. Actually, as we expected, they rely more on plantain, which you see on the lower right-hand side. But they rely mostly on even other flowering plants, which were then in the as weeds in mixes. Thank you for listening.
Thank you, Dick. Now we go to Jens de Hazeleer of Natuurpunt study in Belgium. Jens.
Good morning. So my name is Jens. I'm working at Natuurpunt. I've been working during the BEESPOKE project in 2020, together with VLM and University of Ghent, on making an inventory of wild bees, butterflies and hoverflies in several agricultural areas in Flanders. VLM is a part of the Flemish government, and it stimulates farmers to sow flower strips. And University of Ghent works on modeling of pollination services, but Ivan will talk more about that later. We at Natuurpunt, we were the partner that did a big part of the fieldwork, And today I want to share some results with the focus on a rare bumblebee species, the red-shanked carder bee, a species with a rather interesting ecology. Because the species has a very strong preference for flowers with long corolla tubes, being mainly Lamiaceae, so the mint family, and Fabaceae, the bean family. In contrast to other bumblebee species, they make their nests only above the ground, and they use grass clippings and moss. That's why their name in Dutch is the grashommel, the grass bumblebee. So they make those nests mainly in grassy areas like roadsides, for instance. And in contrast to most bumblebee species, the range of this species is quite small. So that the maximum distance between the potential nesting sites and the flowers it's visiting on can be maximum 300 to 500 meters. Next. Here you see a worker bee of the red-shanked carder bee, and it looks very similar to the red-tailed bumblebee, but that's a species which is much more common and also has a less preference for, or has a wider diet. Next. Here we see some results from the fieldwork from this year. So we worked in a very open landscape, which is called the polders, which you can find in Flanders quite close to the coast. And open landscapes are the preferred habitat for this specific bumblebee species. In pink and in green, you see some flower strips consisting mainly of the Fabaceae, so bean plants from the bean family, and those were placed in the landscape. We visited those in the context of the BEESPOKE project, and the pink little dots that you see all around the map, these were all observations from the red-shanked bumblebee. And this is quite interesting because we have over 200 observations, and in Flanders before this project there was only 20 to 30 observations of this bumblebee species. In red you see a 400-meter buffer around all the observations. And in blue, put the roadsides, so that's the potential nesting sites. And you see that to conserve the species, we have to work together. We have to work together with farmers, and we have to put flower-rich strips in the vicinity of roadsides, but the management of these roadsides also should be preferable for the nesting of the species. Next. If you look a bit more into detail, on which kind of plants we found the bumblebees on, then you see that in spring we hardly found any bumblebees, but that's normal because queens are a lot harder to find than worker bees. They're also a lot bigger, but there's a lot less than the workers. But the queens were mostly found on Astracea and Lamiaceae. And if you look from June and July, you see a lot of workers, and we found most of them on the bean family, so on Fabaceae. In end of August, we also found some new queens that will hibernate through this winter, and that one we found on Caprifoliacea. Next. But if you look more into detail to the family of the Fabaceae, then we see that the preference from the worker bees shifted from alfalfa in June, so that's the green in green. That the preference shifted completely towards red clover and towards fodder vetch in July. So that means that although in July the alfalfa was still flowering, so that means that if you want to conserve the species, you should really look into detail what kind of plant species it prefers. And not just on family level, but also on species level. And you should have a mixture of the right plant species to have food throughout the whole of the flight season. Next. So the next 2 years we will continue working in this area on the red-shanked carder bee, and that should result in more observations of the species. But we will also look more into detail which flowers are really used as pollen sources for the larvae. So far, we just looked at what kind of plant that was visited, but we have no idea. We didn't make the distinction between nectar collecting and pollen collecting. So from next year on, we will collect the pollen as well. So we will steal pollen from the workers to ID and to know exactly which plant species are important. And so we can use those in the flower mixtures. We also hope to find more nests and learn more about management of roadsides that is beneficial for the nesting sites. And lastly, through mark recapture methods, we will look into the maximum foraging distance between nests that we found and between the flowers where we find the bees on. So it's very interesting to work on a specific bee, and I have a very good hope that we will be able to conserve the species in that area, in that high density agricultural area, with the help of farmers. Thank you very much.
Thank you, Jens. And we will go to Michelle Fountain from NIAP IMA. And after Michelle, we have a short Q&A session. Michelle.
Thank you. Good morning, everyone. So I'm Michelle Fountain from NIAB EMR, formerly known as East Malling Research. And we're a centre for horticultural research with a focus on fruit crops. And part of that research looks at optimising pollination in rosaceous crops. I'm assisted by Selena, who helps me to deliver the work and also test the protocols that we're developing. Our work is supported by Holistic Water for Horticulture project and the Agriculture and Horticultural Development Board, which is a levy for UK growers. And in our work package, we're looking at developing biodiversity monitoring tools for growers and then providing training later on. Next slide, please. So currently farmers do consider pollinators, obviously, when they're growing crops, and that might be in the form of introducing managed bees or reducing pesticide inputs, particularly during flowering. But what farmers and growers aren't doing at the moment really is measuring the pollinators that they have in the crops, and also whether they're getting optimum pollination efficacy as part of that crop management. So if you look at the chart in the top right-hand corner, you can see that although honeybees are the most frequent visitors of apple flowers, for example, the picture there shows a solitary bee, and we know now that solitary bees are more effective pollinators of apple. So the type of pollinator is important for each particular crop. Also, growers don't necessarily know whether they're reaching optimum pollination and getting the best out of the wild and managed pollinators around their crops. So in the bottom right-hand corner chart, the red bar is showing apple flowers that we have hand pollinated, and the yellow bars are flowers which are just pollinated by the insects in the environment. And this is essentially showing a deficit in pollination. And in this particular case, we're measuring this as the number of mature seeds which set. And we know that the number of mature seeds in an apple is directly related to apple quality, both shape and size. But it's difficult for farmers and growers to do this without the correct tools. So that's part of what we're doing. So we're developing the tools to be able to do this. And then that leads on to the work that Lena talked about, where we're developing the bespoke seed mixes to deliver to individual crops. Next slide, please. So through the project, we're having meetings with experts, that's policymakers, farmers, agronomists, seed mix companies. And one of the first things that we've begun to develop is the guides, which you can see at the bottom, which enable growers to be able to go into their crops and assess whether they're getting the best pollination. Next slide, please. We've also just started to develop simple field guides, which we hope will become digital as well, to enable farmers to be able to identify which pollinators they have in their crops. So if we start with the picture on the bottom left, and work clockwise, we can see the insect here that's just leaving the flower is a bumblebee. And then the next picture to the right is also a bumblebee, but looks quite different and looks very similar to the third picture, which is a solitary bee. Now, this solitary bee looks very different to the picture following on, and the picture just below that in the bottom right hand is also another solitary bee. Now, this species does look superficially very similar to honeybees, and even honeybees can look quite different when you are observing them in the field. They quite often have different colour morphs. So what we're trying to do is simplify this identification so that people can get a really good grasp as to whether they've got honeybees, solitary bees, bumblebees, hoverflies, or indeed other insects visiting the flowers. Next slide, please. So in summary, we're going to be developing guides which will also incorporate record sheets, so farmers can keep a record of whether the processes that they're putting in place, including the flower mixes, are actually improving the flower visitors year on year. And as part of that, we'll be developing online training videos, which will be translated. And hopefully, when we can all get back out in the field together, we can have some really good events where we can actually physically show people how to do what we've actually practiced. And I noticed a question in the chat box earlier, which was talking about natural enemies and pollinators, but also are we looking at what pest species are in these flower mixes? And that is part of the work in some of the groups. So here, for example, we've got a flower with oxeye daisy, and although it's got a lovely ladybird on it, it also has a species of mirid, which is not good for strawberry production, let's say. So we might want to avoid certain species of plants in the mixes that we're developing for specific crops. And that's me. Thank you.
Thank you, Michelle. Now we go to the Q&A session. I will stop sharing screen so we can see each other. So, John, are there already some questions you want to answer?
Yeah, Michelle's answered one of them. I think one of the questions that's always comes up is whether you can establish wildflower mixes into existing vegetation, especially if farmers have the grass margins or something like that funded under agri-environment, they want to improve them. What can they do to get some diversity into that mix? So I think Jojana is probably best to answer that. If you'd like to have a go, you've already put a reply in there, but
yes, well, like I said in the chat, the seeds need a place to germinate and grow. So to just chuck them in an existing grassland would be sort of useless. There's in general very bad experience with this. So you need, of course, if you already have a nice grassland with some species in and you want to improve it, it would be good to make a little bit of room. But you have to remember that the seeds need room to germinate and grow. So you can make some bare strips in it, for example. That's a stay bare for some time if you want to introduce species.
Okay, we have another couple of experts I can see there, Marek and is that Richard Brown from Emmersgate?
Yeah.
I don't know if they would like to comment on it, their experiences of trying to get mixes going into existing grassland.
I don't mind commenting. And one of the general points I pick up is that what is important is trying to find species that are going to be suitable to the site and soil, and that will include fertility. So the success of extending into existing grass, and whether you need grass with the mixture or not, so much depends on the site and the situation. If you have thin limestone soils, you can achieve so much more than on a fertile soil. So our approach is always to try and maximise the botanical potential of the site, which in turn will maximise the insect and pollinator potential of the site. It's not a case of targeting particular species that aren't necessarily related to the soil.
Okay, thank you. Richard Winspear says in the chat about scarifying and sowing seed onto that. I think my experience is that it works with, if you've got a fairly aggressive plant that you're trying to introduce, like oxeye daisy, then they'll have a good go. But if some of the sort of more delicate species might not get going into an existing grass mix.
John, it's Marek. I'm not very good at these web things, so I don't know how to ask questions, so I've had to unmute myself. In the 40-something years I've been doing this, I would think 80% of the attempts to floristically enhance grassland have been disappointing. The only thing a farmer can do with some degree of success, either in the autumn or the spring, is mow almost 1 inch higher than a cultivation, followed by a disking to produce at least 70% exposed soil, then broadcast and roll the seed. But this is, as Richard Brown says, never as successful as a properly balanced targeted mix from the word go.
Okay, thanks very much. Another question we've got is whether we're looking at provision of nesting sites. We're not actively doing it at the moment. I have a PhD student I co-supervise with Dave Goulson who's looking at this, and she's managed to, she's looking at creating scrapes on farmland, so just creating bare earth using a digger. And that seemed to work very well for some of the solitary bees. She also compared it to spraying off patches, but that wasn't as successful. But what she did find was that the vegetation came back fairly quickly, and as soon as it starts coming back, then it loses its attractiveness to the solitary bees. So I have to keep the ground bare through the summer as different species start to emerge and look for sites.
John, we do provide some nesting habitat next to the grasslands site that we have, and also investigate the success of the nesting habitats.
And Michelle, I think she also has a student looking at this as well.
Yeah, so we've done two aspects of this. So one was in a BBSRC SMOOPS project, which is just being written up now. And by creating extra herbicided areas, you can encourage nesting bees. So in particular, we were looking for apple orchards to try and increase numbers in apple orchards. And I have a PhD student now who has been looking at bee scrapes created at East Malling. And he's starting to identify what soil properties are necessary. So the soil needs to have good infiltration and a particular compaction range, let's say. So it does need to be considered in the creation of these, where they're going to be, the situation to make sure they're normally in a sunny spot and that the soil type is right for creating them. That's for solitary bees, I forgot to say.
Yeah, I see there's also a comment from Sandra in Sweden, who's looking at bumblebee nesting in straw bales, and that works in review at the moment. So I think we're coming to the end of our time for the Q&A. We can have more time at the end, so keep your questions coming in, and I'll pass back to Jan-Willem to carry on.
Thank you. So then I give the floor to Ivan Meus from the University of Ghent with a contribution of Arjen Strijkstra, University of Applied Sciences van Larenstein. Wait a minute. Oh, you can hear me? Hello?
We can hear you.
Okay.
No presentation yet.
No, something went wrong. Let me see. I'll try it again.
Looking good.
Okay.
Now starting things up.
Good. So now we're going to Ivan Meus en Arjen Strijkstra. Oh.
Good morning, everybody. I'm going to talk about tools that link pollination services with the environment. This will enable us to identify areas that need improvement. Pollination is a service often provided by insects. For instance, for the pollination of sweet cherry, bees are important pollinators. Yet, the service is delivered by a multitude of different bee species. And we know that yields increase when the abundance of different wild bees is higher. Thus the endpoint is obvious. Having different wild bees to pollinate your crop is what we want. But how to get there? And was pollination not a free service? How do we get this back? Well, in order to support different wild bees in your environment, you need to understand which landscape elements support these different kinds of bees. To do this, models have been developed which try to predict the abundance of bees present in a specific landscape. Having these kind of validated models, one can simulate changes in the environment and predict the impact of these changes on pollinators and the service they provide. Within BEESPOKE, we are implementing a model originally described by Erik Lonsdorf. What will the model do? It will estimate pollination services for the EU North Sea region. More specific, it will tell us if the pollination service is good, intermediate, or bad at the location of interest. To do this, we start from a regular map to locate the places of interest. On top of this, we project a layer of land covers. For instance, the different green areas you see are different kinds of grasslands or forest elements, each with their own characteristics. It is the land cover layer which forms the basis of our predictions. The more accurate the land cover data is, the better our predictions are. Based on these land covers, we calculate food quality maps, meaning does a specific land cover provide food for a specific bee? Here, the dark gray areas represent places with high amount of food resources. A next layer is the nesting suitability map. Here, orange areas represent those that provide more suitable nesting habitat compared to the lighter areas. These two maps allow us to predict if a successful bee nest can be present, meaning, is the nesting habitat okay? And is there enough food in the surrounding environment? Based on the amount of potential bee nests in the environment, we can predict the likely abundance of a pollinator species in. Good morning, everybody. I'm going to talk about a mason bee, Osmia cornuta. Well, for this one, this is a minor bee. Here we show the predictions of Andrena hemaroya. A different bee abundance can be expected. Based on plants or forest elements, each with their own characteristics. It is the land cover layer which forms the basis of our predictions. The more accurate the land cover data is, the better our predictions are. Based on these land covers, we calculate food quality maps, meaning does a specific land cover provide food for a specific bee? Here, the dark gray areas represent places with high amount of food resources. A next layer is the nesting suitability map. Here, orange areas represent those that provide more suitable nesting habitat compared to the lighter areas. These two maps allow us to predict if a successful bee nest can be present, meaning, is the nesting habitat okay? And is there enough food in the surrounding environment? Based on the amount of potential bee nests in the environment, we can predict the likely abundance of a pollinator species in the crop of interest, meaning the specific bee considers the crop of interest as a food resource and will forage on it. I said a specific bee. Indeed, different predictions will be generated for different kind of bees. This one's here, for instance, this is a mason bee, Osmia cornuta. While for this one, this is a minor bee. Here we show the predictions of Andrena hemaroia. Different bee abundance can be expected. This is because a minor bee nests under the ground, while a mason bee nests above the ground. If we look at the sweat bee, Lasioglossum albipes in this case, you really see a different model output. This is mainly because its foraging distance is much smaller, and its presence depends on local scale elements. But okay, what could this mean for you? For instance, for a farmer, it would be great to know the potential pollination service in your crop. But of course, in the wider environment, there are multiple farmers. So on government or cooperation level, one can start to implement landscape planning to sustain optimal pollination service on a broader scale, benefiting multiple stakeholders. Yet we need tools to do this. Within BEESPOKE, we are implementing different ones. In a first tool, one will be able to put in GPS coordinates to select the area of interest. A field is provided in which the crop of interest can be selected. The crop selection determines for which pollinators the abundance of the pollination service will be predicted. Okay, good. You know, for instance, that pollination services can be improved. But knowing this, how can this be done? Within BEESPOKE, we are developing different kind of flower mixtures. These are there to support pollinators in different countries of the EU North Sea region. We make use of existing models to calculate the added value of a flower strip. The bee steward model, for instance. Here, land use maps are translated into food maps for bumblebee species. It calculates if the environment can support nest development of these species. At the farm level, one can introduce flower strips and see how much additional nests can be supported. Within BEESPOKE, there are predictions ongoing to look at the size and the distribution of flower strips and assess their added value for bumblebee nest development. But also, an individual can do predictions. For this, a final tool based on the Lonsdorf model will be implemented. Here, one can select the crop and the area of interest. And then, the land covers will be shown. Herein, the user has the ability to add an area which will be changed into a flower strip. The web application will provide an estimate of pollinator increase for those pollinators suited to pollinate your crop of interest. Thus, it can be evaluated where and how big a flower strip must be to support extra pollinators, and also to support their valuable service, which is pollination. We highlight that these tools are still under development, and thank you for your attention. Good morning, everybody.
Thank you. There was some technical problems, but it should be fine now. Now I would like to go to Frank Stubbe, head of AES of the Flemish Land Agency Region West, VLM. Frank.
Yes, thank you, Jan-Willem. I hope you all hear me loud and clear. Yep. So I work at the Flemish Land Agency. We are a managing authority for agri-environmental schemes. So we do kind of everything. We go to farmers, try to convince them to start environmental schemes. Also, we give advice. We also control it, and we also give advice to the policy or the key people in our region in Flanders who are responsible to work out policy. So in our project, we are thinking how we could improve our policy in each region. We also see that we are still a young policy in most regions, and we still have a lot to learn. As you know, here we saw already a lot of technical things that we should try to build in somewhere or somehow into a better policy, so we could improve our pollination across North Sea region. Next slide, Jan-Willem. So what will we do in the different regions? So we will start, or already started, to have an inventory of the voluntary measures. So the agri-environmental measures in each state of North Sea region that encourage pollination in each bespoke state and other pollinator initiatives, because we see in some regions or states it's done by agri-environmental schemes or measures, and in others it's incorporated, like in Denmark or Sweden, it's incorporated in the greening. So it's totally funded there by Pillar 1. In other states it's partly funded by Europe and partly by the region. So we look how the schemes are constructed, how it's already taken in the different regions, how is the level of remuneration, and how are farmers motivated to start with this measure. We look at land managers and farmers and how it can be incorporated within farming systems locally in each region. So we are managing authority of Flanders, but we also hope to involve the other managing authorities in the different bespoke regions and also national agencies. Next slide, Jan-Willem. So what we will compare is the administrative aspects. How is the administration done? How is the advice in each region being worked out and done into practice? What are the conditions to step into an IAS or a pollinator initiative in each region? How is the content of the scheme and the measures constructed into policy in each region? And the payment. Our goal is to compare how things are done, to detect similarities and differences. It's not to judge in which region is the IAS the best system, but it's to learn and to bring best practices across Europe. Next slide, Jan-Willem. So how we will do it into concrete? We will make in each region a SWOT analysis of the national IAMs or the local greening when it's constructed in greening. We did that already in Flanders. Due to COVID, we did it online. Normally we should do it in real. We hope that in the future we can do it more in real. So we will involve farmers, advisors, managing authorities, non-governmental organizations, experts, all kind of organizations that are involved in pollination. We are trying to set that up in Flanders and to make the SWOT. Then we hope to compare the SWOT between the regions and make an international SWOT. What are the strengths, the weaknesses, the opportunities and the threats of our policy. And we will try to bring that feedback of the international SWOT to the local stakeholders again. And these ideas, we hope that these ideas could be built into policy to improve policy in each bespoke region. That's all, Willem. Jan-Willem, I'm clear. To the next, go to the next speaker, please.
Thank you, Frank. So from Belgium, we go back to Friesland, the Netherlands. My name is Jan-Willem van Kruijsen. I work for the province of Friesland. This partner is responsible for bespoke communication. Outreach is a key component of the project, and we deliver this through the network of demonstration farms, knowledge exchange events, training materials, and guidelines through a variety of modern media. A project website and social media are used for engagement of land managers, policymakers and end users, especially those outside the partnership that want to learn from the good practices and learning outcomes of the project. We regularly generate free publicity throughout the project in the form of press releases, long read articles, video content, newsletters and online magazines. We involve experts in the fields of both the collaborating organizations and beyond. During the entire project, we give a peek into the kitchen of the organizations and we disseminate the knowledge and output of the project. Now we do a lot of presentations. In like September last year, we did a presentation of BEESPOKE at a meeting of the European Deltas in Comacchio in Italy. In February this year, we were at the European Committee of the Regions in Brussels at the conference Halting the Loss of Pollinators, the Role of the EU Agricultural, Regional and Development of Cohesion Policies. And last October, we were present at the EU Green Week 2020. We produce publications like a leaflet, How to Successfully Establish Perennial Wildflower Areas. We publicize and promote new methodologies for measuring levels of pollinators and pollination. By do-it-yourself video blogs, those are technical training videos, land managers and policymakers share expertise, tools and knowledge to instigate bottom-up change, creating more sustainable and resilient ecosystems. Partners conduct dissemination events at demonstration sites to show target audiences the impact bespoke solutions can deliver. This will help ensure the local, regional and national stakeholders are aware of the bespoke solutions. We also collaborate with other EU projects like Science of the Bees, Delta Lady, Klima Repair, etc. So that's something about communication, and I think it's good to go back to a Q&A session to answer all the questions. John.
Yes, so we've had a question about whether glyphosate has an impact if you're using herbicides to clear ground before you sow your wildflower mix. So Michelle's started to answer that. So do you want to carry on, Michelle?
Yeah, so in the trials that we've been doing on our bee scrapes, essentially, and I think in trials by other research groups as well, we're applying a herbicide, glyphosate, namely, as and when necessary. So when the vegetation starts to get too much or too high, the solitary bees are less attracted to it for nesting. So that's when we go in and put a glyphosate on. We haven't seen an impact of that either in terms of the survival of the bees over the winter, and indeed they emerge and then return to nest. So we're not seeing any direct impact. And as I said before, it seems to be more the location of where we put the bee scrapes and the soil type that's more important. But then my other comment was just to note that obviously the widespread use of broad spectrum insecticides does reduce weedy species, which are also obviously flowering as well. So the use of broad spectrums can reduce the amount of forage in a landscape.
Okay, and then related to that, Richard Winspear had a question about whether we can assess success relative to different insecticide regimes. I guess you're meaning there the intensity in insecticide use and whether there's then the benefits might not accrue as you might expect if the bees are being hammered by insecticides. I guess the only direct examples I can think of for that is when we compare organic farming to commercial farming, and generally there's more pollinators and a higher diversity, but sometimes it's difficult to tease about other management practices such as weed management and lack of resource, or how the crop is managed overall. So
I'm thinking of apple here, so tree spacing and how the ground under the trees is kind of prepared and maintained. So in general, I guess insecticides by their very nature act on insects, but the effect of those insects depends on the target sites and how much those insects come into contact with those insecticides.
I think that's a danger with any measures that you're proposing where they actually go within the crop, and there's a risk then that you're sucking the beneficials into the crop and then constantly hitting them with an insecticide, whether it's intentional or not. So avoiding drift into these areas is of course of extreme importance, but it's not something we're looking specifically at in Bespoke. Someone asked about Brexit, but the program, the Interreg programs, has said that all the projects will continue as normal with UK partners.
Someone also asked if we're looking for sites, and the answer to that is yes. And I think depending on which region you're in, if you contact the person on the Bespoke project who's in your region, I'm sure they'll be glad to hear from you and help you set up a site.
There's another, do we have sufficient knowledge on the actual performance of the different agri-environment measures in terms of net, is that net potential, but actual flower, not potential, but actual flower resources provided? I think a lot of the, certainly from the UK point of view, a lot of the measures are evaluated before they're released, so, and that continues afterwards. So I think we do have, and I certainly have evidence of the different types of measures out there and their value for pollinators. And I think that's probably true of a lot of the European countries. There don't seem to be any more questions though.
Okay. So
here we are. There's, what are the impacts on soil-dwelling invertebrates when clearing ground with glyphosate? I mean, glyphosate, I'm not aware that it has a direct impact. And often soil cultivations can have a bigger impact on soil-dwelling invertebrates than the herbicides. So if you're using very intensive soil cultivations, a power harrow or something like that, then that will affect other beneficials that might be living within the soil. Do we tend to compare successive margins on organic or conventional farmland?
I think there's more evidence for persistence of neonicotinoids in margins having an effect on wildflower margins sown on them. Anybody heard of that?
Yeah, I mean, that's one of the reasons why they were banned, was because of the potential impact and build up in margins. So there is evidence that with neonics, the products can get through into the nectar and the pollen. We have new systemic insecticides coming on the market, a new one from Syngenta, I think, so we want to keep an eye on as well. So Rosie says there's something about the negative impacts of glyphosate on honeybees. So we need to have some caution. Of course, glyphosate is going to be banned in 3 years, I think. So the problem will disappear. But it is a useful tool. We have to balance out the possible negative effects and also the positives in terms of it allowing the wildflowers to establish well. So it's always difficult. There's never an easy solution.
So I think like with the neonicotinoids, when a product is removed from the market, you always need to consider what the substitute is going to be for that. and whether the effects of that substitute are actually going to be worse than the original product in terms of, I guess, damage to insect populations. So that's something to consider when people are driving forward with banning particular products.
So Clooney's shown there's a report out that might be of interest to everyone. So if you want to take a note of that. And Frank says, yeah, the biggest challenge is having good seed mixtures at a reasonable price. And certainly the farmers take that into consideration. And so they might go for the sort of standard mixes, which often just encourage the common species. So we're always advocating trying to get more diversity out there. Plant diversity really is the key thing for a lot of these species. But that's a challenge, and perhaps that needs to be reflected in the remuneration from regular environment measures, so that the farmers are rewarded for that extra cost. Yeah, and we always advocate using local seed mixes. These are best suited for your soils and are going to be better adapted not only to the bumblebees but any other host plant, any other species, insect species which they're hosts for. We know there's evidence that local provenance can have an impact on, for example, butterfly larvae and their success. Mark's asking his views on wild cultivars versus agricultural species. I don't know if Janica wants to answer, or Richard.
Well, cultivars and agricultural species are not my expertise, sorry.
I can add a bit that it is important to use the right sort of species and using wild forms in general, but there seems to be a move away from being very localized in the sourcing of the material that we use, and possibly even more so with climate change. What is suitable locally now is not necessarily going to be suitable, and some wild sites have limited genetic diversity, so there's an argument for mixing up. So there's no genetic consensus on whether local is best. In fact, it's moving away from that a bit. Flora-Cal in our country now has sort of gone into recession because people are a lot more interested in the right species rather than the right provenance.
Yeah, and perhaps also local seeds may be rather expensive in comparison to seeds from much further away.
Yes, there are also some very good local initiatives for conservation where the soil and the conditions and the users are very well briefed using a wildlife trust, and there are some very good local initiatives, but they are very special projects, and we need projects that can be rolled out on a much bigger scale for connecting road verges and farm margins where the potential is not so special.
Okay.
There's also a question here about local, but that's a sort of a question that needs to be answered in differently in different countries, I think. For some ecologists, a local means within 1 kilometer, but practically for a seed producer, you would need a bit larger area, like a country or perhaps even bigger, depending on your country and how many different landscape types you have in your country, and where the plant species are from, and if they're genetically compatible to the soil and the environment where they are applied. So local is sort of a difficult word still.
There's a question about with the removal of neonics, whether there's negative effects because there's now multiple applications of insecticides, for example, on oilseed rape for cabbage stem flea beetle. That was always a risk with these products, and there are multiple applications, and they're often ineffective as well. Neonics did have that advantage of not requiring foliar sprays. I'm not aware of any trials that were ever done to look at that, even though it's something I would have supported. To look to see what the balance of the total impact was from neonics versus multiple foliar applications. Work that should have been done really, but it never was, as far as I'm aware.
Okay. Any other questions?
So someone's asking which seeds are local, the seeds produced in the local area or only wild or locally grown plants. There are different approaches, such as growing your own, using green hay, for example, so cutting existing areas and spreading them that way. It's one option. And of course, the seed producers like Emmonsgate and Joe only have limited number of sites, I suppose, that are producing the seed. So you can't always be exactly local.
Yeah, there's been whole conferences on what is local and never come to a conclusion because each plant has its own breeding system and pollination system, and the genetic variability is so individual that nobody's managed to quantify it. But the key thing is having approaches that are proportional, horses for courses, as we say, so that if you're next to a triple SI, a nature site with good soil, you use green hay, use local material. If you're doing a farmland or an urban scheme, then you can be more relaxed about your provenance.
Marek says there are some studies looking at neonics in honeybees, which is now dropped. But there is considerable damage by repeated pyrethroids. Yeah. Yeah, that some farmers were using both products. I mean, we were aware from our studies of long-term monitoring in Sussex, where we measure insecticide use, that actually, and also some of the farmers weren't even aware that we were using neonics. They just bought seed and weren't aware that it had been dressed already. And so they were already doing a combination of the both. I think that was particularly true with cereal crops, but that's a different story, and perhaps the risks there to bees was less.
I guess that's the same thing that's going to happen with glyphosate, John. I wonder if Richard or Marek know what the alternatives will be for reducing weedy species if glyphosate is removed.
Can I comment on that? As far as I know, there is insufficient evidence I can't think of a safer or better way than managing weed problems prior to drilling than glyphosate. The alternative may be residual herbicides in the soil, which I think potentially are more damaging. We know beyond any reasonable doubt that the other form of weed management would be cultivation. And that compared to glyphosate, it would just be a huge step in the wrong direction. Just to comment on neonics, and Michelle, you picked up on this. Be very careful of what you wish for or ask for. Neonics, their damage was perhaps promoted above a realistic situation. Everybody perhaps in the clamour for headlines has forgotten that it is the dose that makes the poison, not the fact that you found it. Piddle in an Olympic swimming pool is easily detectable, but people still swim in the pool. I think this clamour to go green at all costs could well come back to bite us in the future. unless the people that are pushing for these changes actually have a better understanding of the whole agricultural situation.
I think that's very true. It's always, and you've always got to balance things out. There's pros and cons from most measures, but it's the final outcome that matters when you've assessed everything.
I was part of a 15-year project on heavy land near Buckinghamshire in Oxfordshire, 2,500 acres. We split this estate into 4 replicates. Each replicate had business as usual, and then the requirements of cross-compliance, and then habitats that I thought we should and could have. The net result was that the bits, the rest of the farm, we took out 8% of the farm. The farm continued to farm and actually made more money. The wildlife went through the roof because we plugged in the appropriate habitats. And this was at a time where oilseed rape was 1 year in 3, sometimes 1 year in 4 on this farm. And I've spent 50 years believing that if you have something like 3 to 4% of your farm into quality, underline the word quality habitats, there really isn't a problem. If you go to sort of rewilding, etc., the problem then might well be human starvation. There is a very effective balance between quality habitats and allowing the farmer to continue farming whilst you're giving him the right level of encouragement and training on things environmental. We're great, I'm sorry, but this is something I feel very strongly about. We're great at inventing problems that don't exist. We know full well if you sow flowers, you get insects. Get on with it.
All right, thanks, Marek. There's a question here about earlier on from David Lyles about mixes and using perennials in them. I think the question is about how can we make sure that these mixes have good persistence over a long period so they don't need resowing. I know the sort of traditional legume mixes often get dominated by grasses and fairly quickly. I don't know if anyone wants to comment on how you can ensure that your mixes have good persistence through the year. I guess it's a management question.
Can I comment on that again?
Yeah, I'd like to ask the seed producers as well, of course.
Well,
Yeah.
oh, sorry, Richard. Like you said, Richard, it's for one part, it's very important what species you pick for a particular site. So they should be suitable. If the soil is very fertile, that could be a problem for many wildflower species. So I think that's one really important part of this design, but also, of course, the management. I mean, the sowing at the right time, preparing the soil, it makes a great part of the success. But like in the Netherlands, for example, farmers find it very hard to remove the cuttings and in fact are smothering the vegetation. So I think, yeah, there's many room for improvement on this part. But Richard, do you have something to add?
Yeah, one of the most common questions that we get is, can I sow more flowers and less grass in the mixture to make a difference? And I always say it doesn't matter what the ratio of flowers to grass seed is, that you will always, the ratio that you end up with will be determined by the soil and the fertility. So if you don't sow any grass, you will still get grass. It's in there in the environment. So if you have a fertile, rich farm margin, and whatever you sow, it will become dominated by grass eventually. I remember years ago, Marek had a demonstration farm where they soil mapped the whole farm and estate by a computer and picked out the best soils, the flowers, and that was a very successful strategy.
So I have a question for the seed producers then. So in the life of an orchard is around 25 years. So if I was to sow in the alleyways in year 1, how long, if I managed it correctly, according to your recommendations, what kind of life would you think I would get from those alleyways?
If the soil type was good, forever. It'll get better with time, and you will have orchids come in. As Roger Smith from Newcastle University looked at long-term meadow improvement in the Yorkshire Dales, and he believed it took 15 years for the soil microbes to balance, and then the conditions can correct for orchids to invade. So there's no limit to this, but you have to have the right soil and the right management throughout that period.
Agree.
And can you comment on the long-term management?
A big subject, but there seems to be a big debate between people who want to promote very late cutting supposedly for insects, and following traditional meadow management, which means a midsummer cut. And I always look at the graphs of insect activity and pollinator preferences, and I think my view is that a lot of insects are co-adapted to be at the most pollinator foraging time during June and July, after which you can cut for hay and maintain high diversity. But alongside that, I would say you must have also the habitats for nests. So you need rough grassland, but they are usually not in short supply. Having rough unmanaged grassland is not difficult to create. Having well-managed flower-rich grassland is harder.
So one alternative approach for my orchards might be to do a summer cut on every other row, and then on the alternate rows have an autumn cut, for example. So we're increasing the complexity within the orchards.
Amongst people generally, there's always a tendency for look for black and white, which is the best way to do it. The best way is to have a mosaic, and so that in my own meadow, I use a scythe, so I can start cutting in the end of June, which is traditional hay start, and I keep cutting right through to September, October in sections and vary that. So it's mosaics and interconnectivity of those different habitats that's important, not just either or.
And in terms of, we have agri-environment measures, they're often quite rigid in terms of the guidelines. Would you like to see greater flexibility in there so that the farmers can adapt, or advisors can give them some information about when they should cut?
A lot comes down to practicalities, what equipment they've got, whether they can actually dispose of cuttings. Disposal of cuttings in an urban and a farm setting is quite a problem, and it's quite important. So I think there needs to be flexibility, and farmers need to be empowered to be able to manage for wildlife, understand what they're aiming for. They understand how they're going to achieve a yield of corn from their fields. They need more help to guide them into how to manage for insects, and that is where this research is so good, because it gives them tools to do that.
Right. Thanks very much. We've overrun our time, so I guess I ought to draw it to a close now. There's a few more questions come in. I haven't had a chance to look at those. But do feel to keep in contact with us. There's questions about hedgerows in there as well, which is another aspect that we will try to look at in the project. So I think the evidence at the moment is that if we can use approaches such as incremental cutting, that's been shown to be some of the best for hedgerows in terms that you allow the hedge to flower.
John, there is just one question on mycorrhizal spores helping flower establishment. So as part of the BEESPOKE project, this autumn we did sow the blackcurrant demonstration plot at East Malling in a replicated plot design of wildflower seeds with and without mycorrhizal amendments. So hopefully, if it's worked, we'll be able to report on that in the next couple of years.
Okay. And there's one question there about Dutch waterboards. Is there any representatives about that? Whether the longevity of their flowery, strong dikes and how they can manage them. No, I think not.
No, there's nobody from the Dutch waterboards. No,
Okay.
not that I know.
I can say that when you're talking about Dutch dikes, it's the type of soil has so much influence on the type of vegetation that you can develop, and people think they can establish flowers everywhere, but it's sort of well, luckily there's many dikes that are more sandy and not so fertile. So there's some possibilities there actually for long-term management.
Okay, well, thanks very much everybody for joining us today. And thanks for all your questions. It's been really good to have such responses. And hopefully this will be a regular occurrence. So if you don't mind, we'll keep your contact details and let you know when we next run another webinar with an update on research and outputs. Keep an eye on the website and the Facebook page, of course, for further events. There may be local events that you'd like to attend. And hope you all have a good Christmas. And thanks again to all the speakers as well.
Yeah, thank you all. And the video recording will be available on the BEESPOKE website and social media. There you can also find our contact details. And we will also send around a survey, but you can also start filling out the survey already. John will make a link in the chat. And yeah, looking forward to see you next time. Thank you so much.
Thank you.
So it should be there then, the survey, before you all disappear. I think everyone's going now.
I'm still here.
Jan-Willem, we stay a bit longer with the hosts?
Yeah, we can do that.
Maybe you should stop recording then.
Good idea.